Our next speaker is our gold sponsor. Our gold sponsor was Aerotech from Washington State, and our speaker is Todd Leighton. Todd is Director of Experimental Products at Aerotech with 26 years in aerospace. He leads hardware development projects and specializes in low-speed aerodynamics, wind tunnel testing, and integrated systems flight test. His experience spans light aircraft, commercial transports, FAA certification programs, and landing gear structural design. Todd brings deep expertise in validation testing to support both design and certification goals.
All right, first of all, we got to deal with the elephant in the room. When I'm talking about novel propulsion systems, I am not talking about Ken's version of novel propulsion systems. All of these things that I'm going to show you are real systems. They have been tested. They are all at different TRL levels. But that's part of what Aerotech is here for, is to bring those types of new novel systems to fruition, get them from a low TRL level state to a high TRL level state. And a lot of what I'm going to be focusing on here is the importance of understanding the failure modes in these systems as well, because it really ends up being the integration issues that ultimately end up being a large part of how to make a productive, functional propulsion system. Here's my least favorite slide in the deck, talking about myself. You got the bio. I've been doing this a long time. A lot of experience in test, a lot of experience in wind tunnel test and in functional component level testing. But my core experience has really been in external aerodynamics. So it's a pretty broad array of skill sets. I am a Part 23 structures TER. Not much to do with external aerodynamics always, but those two things have kind of come together to bring a lot of experience in testing overall, and how do we get to truly, high TRL level technologies that really, actually get to through certification. But the most important thing I think I want to say here is actually that, is when you stand up on, and do these kinds of presentations, largely what's happening is I'm presenting my team's work, not my work. So there's a lot of effort that's gone into any one of these test programs that we've talked about, and a lot of it is the result of a great team behind me. So I'll say that up front. Nope, wrong button. There we go. All right. So Aerotech, a little bit about Aerotech. The Aerotech's mission statement is truly accelerating the evolution of aerospace, and that's not just a tagline we throw out there. That is core to what we do. At our heart, we're a design, build, test organization. We were centered around that from day one, and that's what we continue to do. And as I said earlier, our main goal is to help customers bring low TRL level technology up into, as far as they want to run with it. Sometimes it's never meant to be certified because it's truly an R&D type program. So you get it to a state where you learn what you need out of it, and then you move on to a different design. Sometimes it's, as with Magna-X, we've been working with Magna-X for a long time. The goal there is certification. And, we walked that journey in parallel with them for quite some time, and we're very excited to help them get to a full certification state. So what we're talking about here, though, is specific to a lot of the propulsion system testing that we've done. The scope of what Aerotech does is much broader than this, but for the conference that we're talking about here, and we've kind of centered that down to propulsion systems. We've been dealing with electric propulsion for quite some time now. While Magna-X brings the core technology in terms of motor development, that's not our IP. We don't want it. But we are part of that, getting to integrate that and making it a fully functional propulsion system within these airframes. We did all of the integration work of the cooling systems, the motor mounting, and the energy storage system within the Caravan program. And that was a big program for us. There was a lot of learnings, as has been said, along the way. A lot of things we found during tests, especially that first flight. Ben did a great paper on some of the failure modes of that and the things that we went through to uncover what happened on that first flight. So I won't go into that here, but I encourage you guys to go back and take a look at that, because it's a lot of what I'm talking about here is actually, the fallout of that. It's really understanding what happens in these systems, especially as they get more complex, the need to be able to go and test those at not just a component level, but a system and a fully integrated propulsion system level. In that particular program, we had a failure of the propulsion system on first flight. There was no single failure in any of the components and nothing that was destructive, shall we say. Nothing truly failed, but the system shut down, and that's a failure of the overall propulsion system. We spent a lot of time trying to dig that out and figure out what happened, and ultimately we did, and those learnings have gone into that system, and there was nothing that was, directly involved in the propulsion system, but you had an ancillary failure that caused the whole system to shut down. That was an integration problem. That wasn't a propulsion system problem directly, but it was an integration problem. All of that has been taken. We did a lot of system integration development work, system safety analysis went into the aviation ALICE. And we were, again, parallel in that process to help aviation develop a truly integrated electric propulsion system all across the airframe and everything that they put together in that. We spent a lot of time working with them to do the system safety analysis to get to the point where we had a safe, functional aircraft as a whole. We're now working with Surfair as an extension of the eCaravan program to get that to full certification, so taking those to the next level and bringing that TRL level up. Universal Hydrogen program was a major program for us. Ben did a great job of showing some of the pretty pictures of that, so that was great. It was good to see. We did all of the system integration work for that airframe, all the fuel system integration work, again, not our IP, but we needed to be able to integrate that safely within the system and understand it at a deep level. And that's the other portion of it, is that as integrators, you have to understand how these systems can potentially fail. We couldn't rely on the system under test to self-diagnose those failures, so we actually had to come up with secondary safety systems that we could rely on that were completely analog, that we didn't have to spend a lot of time testing. But we did that because we needed to assure a level of safety, even for a technology demonstrator. It's been said earlier, we really can't afford, the kind of catastrophic failures that is going to show up on the news. As an industry, that's going to be hurtful for everybody. So even at a technology demonstration level, we have to focus on a lot of, how those systems go and work and play with the airframe as a whole. One of our current projects is, again, in parallel with MagnaX, is we're doing the NASA EPFD program. A lot of work has gone into that. And that is really the goal of that has been said, is to carry this electric propulsion system forward to something that's truly operational and something that is understood at a deep level as not only how do you integrate it, but how do you operate it. And then what we're going to be talking about a little bit more today is what I refer to as a truly novel propulsion system. It's very different from anything else that we've worked on. We'll deep dive a little bit more into that, but it is functionally, and it was what Jet refers to as a fluidic propulsion system. It is, I think, truly a novel system from the standpoint of it's entirely different than most other propulsion systems out there right now, and it has some very inherent strengths. Also got some weaknesses, like every system, but it's from a test standpoint, that's what we're working through right now. Figure those things out. How do those systems respond? Where do we use them? Where do we have to mitigate some of the shortcomings? And this is true for every propulsion system. You've got really kind of three main areas that you have to deal with one way or the other. You got the performance of the system, right? That tends to be the core IP of the companies that we're working with, MagnaX, Jet, development of thrust, and to do that efficiently. But that's only one part of the problem. The cooling system development, how do you cool those components? And every system's got its own unique issues that go along with that. The Jet system that we'll talk about in just a minute here has some very unique strengths to it, So a lot of these cooling issues are not a problem that it would be for a more traditional system. But there are components in it that we've had to figure out how to cool because of the way that the system functions. And then of course as I've mentioned, the integration of these systems is key. How do you make these systems truly fully functional and work and play with the airframe? If you've got a legacy airframe, you're stuck with certain aspects of it, right? There's certain things you just cannot change. But there's things that you must in order to make the system effective. In order to make the propulsion system as efficient as it can be and to truly utilize its strengths. That becomes a lot of the core work that we do. The NASA EPA program is a perfect example. The cooling of that system has been something that we've spent a lot of time on and working through how do we effectively cool these systems and do it in a way that has the least amount of impact, particularly in drag, on the overall airframe. We've spent a lot of time doing that. On the eCaravan program, cooling drag was, and cooling of the system overall was a big focus of that program. So let's talk a little bit more about Jetoptera's system, and I will say that Andre Evolut is in the audience here somewhere. Their hand up. I encourage you to go talk to him. This is a system that while I've got some experience with now, he's the real expert in the core propulsion system. So if you have specific questions on that, feel free to go track him down. One of the key features, it's got no moving parts. We've heard that in some of these presentations already, and you just kind of think about how important that truly is in terms of the operation and integration of a system like that. No moving parts to an engine or to a thruster, rather. Now, I will say that a little bit with, while you can't completely remove it, this is what I would call a segregated propulsion system. The thrust generation portion of it is segregated from the power generation. That has certain advantages, but it also means that you don't completely eliminate all moving parts, right? If you've got a turbo generator powering this, for example, you've got rotating components, but you can isolate where those components go. The impact of that, I think, is hard to understate because things like rotor burst zones, the regulatory requirements are written around turboprops, turbo generators, and having rotor burst zones, built into your design. That's not an issue here, at least not for the thruster. There's no vibration issues that go along with that because you have no high inertia rotating components. There's no vibration issues that go along with that as well. For those of you that have worked on helicopters, you know just how big of a deal that really is. There's no blades. Ultimately, that yields a much safer operational system, but it also has secondary benefits, things like, bird strike. You've got no moving parts for a bird to actually impact. While you still have to deal with bird strike on some level, the problem doesn't completely go away. You don't have to deal with the problem of a bird going through the thruster. It doesn't affect it. Response time. So one of the key aspects to this, which is particularly important to the VTOL world, is the thruster's response time is not limited by the inertia of the components because there's nothing rotating inherently. So its response time is on the order of the response time of the valves that are controlling the pressure to it, which is about on the order of about 50 milliseconds. That is at least an order of magnitude faster than most other propulsion systems. And if you're coming in on either takeoff or landing, that's a big deal. Your control system now doesn't have to deal with a large lag response time. When we were working on universal hydrogen, that was a major problem for us. It wasn't that the electric motors couldn't respond fast enough. It was that the fuel cells that were powering the electric motors have a very long response time in terms of aviation environment, quite a few seconds generally. You're going in on short final and you got to do a go around, that's a big deal, right? If you've got a 3 or 4 second response time in terms of your thrust generation, that can be a problem. These systems don't have any of those issues. Acoustics, we talked about, a lot of people have talked about acoustics. This system because it has no rotating components, there's no beat pulse associated with it, right? So what you get is basically broadband noise associated with it. And the testing that Jetoptera has done, and again, this is based upon test, is it's functionally based on the acoustic signature that you get is like the wind. It's essentially in that 65 dB kind of range, but it's broadband noise. You can't discern it from other things that are happening, like say, a strong breeze in the background. That has significant benefits when you're talking about confined spaces and how these systems will ultimately be used and get affected by small landing zones. It's energy agnostic, meaning that you can power this by a traditional turbo generator system. You could power it through fully electric system. As we get to systems that can produce the kind of power necessary, and because those systems are separated, it's easy to change from one power generation system to another because they can effectively be interchanged without changing the thrust delivery system of it. The other thing that's maybe not well understood in this is that it's shape agnostic. What I mean by that is that the shape of these thrusters doesn't have to be limited by, they don't have to be round, they don't have to be oblong, they don't have to be square. You can change that based upon the integration situation that you're working with, and that buys you a lot of value based upon the type of installation that you're actually working through. So, as with all systems, you've got strengths and weaknesses, right? With any sort of really novel system, you're going to have novel failure modes as well. These systems are, it's very cool from the standpoint of no moving parts, right? But you also have failure modes that are unique to this type of system. Show a quick video here. Looks like we're not getting the sound. Oh, there we go. So if you caught that part, and I don't know if I can back up and show that again, but what we saw there was the essentially implosion of this thruster that we were testing. The first thing I want to say here is thank you to JetUpTerra for letting us show this video in the first place, because most companies don't want you to show their designs coming apart. What's important here, though, is that number one, I'm a big proponent of sharing these kinds of failures. Right? It's incredibly important for us as an industry to look at these things and to learn from them. The other thing that you don't see here, and it's maybe not immediately obvious, is that what you see in the background here is that this is the system that we tested in our hangar. Right? When we test Magnex's system, we're way out of way, right? Because if you lose a prop, it's a major event. Now, it's not that that's very likely, but we have to plan for that as a test organization, right? Stuff happens. This is why we test. In this particular system, because there's no high inertia components in it, there was no need to actually do that. We could allow for that, and it makes it much faster for us to be able to test. The other thing that's pretty unique about this is that we predicted this failure, actually. What we didn't know at the time was how conservative we were being with some of our analysis, because we didn't have a lot of the coupon test data that would go along with some of this. And that was the reason why we tested. And we found out that we actually weren't very conservative with our analysis. The margins were actually correct. We had some negative margins. They were fairly small. So we figured, hey, let's go ahead and test, figure out, fail quickly, and where do we need to fix it. The other key thing in this is that, so this is the next generation of that. That test that I just showed you was about a month ago. The time between now and testing a brand new thruster, completely redesigned, we changed materials, we changed design overall slightly, and we're now already at the point of testing a new version of that thruster. So this type of rapid iteration is only possible because of the fact that the system is inherently allows us to be able to do that. If you have no moving parts, you don't have to redesign a whole compressor, right? Had this been a more traditional system, it would have taken us months to probably redesign, remanufacture, and develop a new thruster to get back into test. We're already in testing on a new version of this. And that kind of rapid development is really important for us as an industry to be able to get these kinds of things and these designs to a high terror level quickly. So what do we take from all of that? First of all, we need to have a deep understanding of each of these systems. The more novel the system is, the more you got to dig deep into it because they're different. If purely by the fact that they are different from what we're used to doing, you got to dig into it, and you have to understand it on a fundamental level and understand how these things come apart and when they do, because ultimately they will, right? At some stage, you're going to find a failure mode that somebody didn't think of. Hey, I never thought of that. That's why we test, and we have to test at a not only a component level but a system level, and all the way up through a fully functional propulsion system. Mitigating these failures. So what did we do with Jet Optera? We changed materials in that case. We've gone to a fully carbon thruster, which we didn't do initially because it was hard, quite frankly. It was hard to get the design and the shape that we wanted out of it, to get the performance that we needed out of it. But the testing showed us that that was a must. We needed to move towards different materials, so we've done that. A lot of times we would rely on technology, or we would rely on current FAA requirements. In these kind of cases, we can't do that. We ran into this a lot with universal hydrogen. Things that were regulatory requirements that were generated for other applications that get applied to it just didn't apply to us anymore, and we had to step outside that box. And then, in this case, we've had to update our analysis, right? You got to update the tools, you got to figure out the nuances to it and get better analysis. Skip forward and just cut to the punchline here. Again, more novel these systems, the more novel the failure modes are going to be, which is important for us, particularly as a test and integration organization, to truly understand that. But comprehensive testing becomes the only way to really validate some of that. And as the systems get more complicated, especially the control systems associated with that, understanding how those things can fail is really important. And at that, I will leave it there. Thank you very much.
Okay, so this is our second eVTOL industry panel. Our first speaker is Christian Costello from Beta. She just arrived in Oshkosh a few minutes ago, so the dedication of our speakers to get here on time. Christian manages regulatory affairs for Beta Technologies. She leads in her role, she oversees all policy guidance and rulemaking and acts as the integration focal to develop Beta's regulatory position on matters relevant to the success of the business. Prior to joining Beta, Christian worked as executive management for a UAS company and management of a Part 135 operation. She flew as a corporate pilot in Part 91 and Part 135 operations in a Cessna Citation XLS and XLS Plus and CJ series aircraft, and worked for Flight Safety International. She began her aviation career working as a flight instructor and check airman at Kansas State University's Part 141 Flight School. She received a BS in Aeronautical Technology at Kansas State University. Please come up and present.
All right, good afternoon, everyone. Welcome to the big show, Oshkosh. We're here, finally. It feels like it's been, planning and all the preparations, and exciting to be here with you all to kick off what's going to be an excellent week. So as Ken said, Kristen Costello with Beta Technologies, lead regulatory affairs for the company. I've been with the company for about a year and a half, and it's been a journey. We are based in Burlington, Vermont, and we will have a big presence at the show this year. So we have brought in 2 of our electric aircraft, our conventional takeoff and landing aircraft, to be here at the air show. So we will have our passenger configured aircraft on static display at our booth, and we will be flying our cargo configuration CTOL in the air show a couple of days this week. So be sure and come check it out. So I thought a lot about what I was going to talk about today. And my last VFS event was in February of this year. And, I didn't want to be duplicative and, run back through all of the, the same things again. And it's been a really big year for Beta. We've done a lot. And so I thought, we're here at the biggest air show in the US. So let's talk about the flying that we've done and kind of the journey that we've been on thus far this year. So again, Beta Technologies, so we're an electric aerospace manufacturer based in Burlington, Vermont, and our goal is to develop solutions for aviation that are safer, cleaner, and more cost-effective. So we're developing not only aircraft, but also on the infrastructure side, we're developing charging solutions. So looking for full options for our consumers for cargo logistics, medical, and eventually passenger missions. So to give those of you that aren't familiar with us a little better idea of who we are and what products we currently have. So right now we have 3 concurrent certification projects underway with the FAA. So we've taken a thoughtful approach with this. Backwards. Am I hitting buttons? There we go. Thumb off. So we're taking a concurrent approach here, kind of stepwise. So we're starting with our H500A series, which is our all-electric engine being certified under Part 33 with special conditions. Our CTOL aircraft, so again, an airplane that's being certified under Part 23 with no special conditions. So using the existing regulatory frameworks. And then our VTOL, which is currently a 2117B project. So what's really interesting about this is the stepwise approach, the integration piece. So H500A ports into the aircraft, and then also the commonality between the 2 aircraft systems. So we have roughly 75 to 80% commonality, which eases the path to certification, and there's also training benefits. So when you look at like our training syllabus between the 2 aircraft, actually the first 3 modules are the same. So if you have the basic CTOL knowledge, transitioning into the VTOL, you really only have 2 additional modules that you have to go through. Let's see. We'll go into the flying here. This is more fun. Let's go to the video. So I'm going to talk through a lot of this, and this video is, just kind of a compilation of some really great flying that we've gotten to do over the past year. So to recap some of our accomplishments leading up to 2025, we did 5 years of piloted flights on full-scale aircraft. We've flown the world's first crewed full-scale transition flight on a VTOL. In 2024, we completed the first flight of a production intent CTOL from our production line in Vermont. Operated in some of the busiest Class Bravo airspace, including flying the Hudson Corridor in New York. We completed 4 military exercises with 100% availability rate, performing simulated casualty evacuations and asset repositioning, and flew aircraft across 90 plus airports in the US and Canada. We received FAA approval to begin dual-seat training in our initial cadre for the eVTOL aircraft, and we also began IMC testing. So this year, our goal was to hit even more real demonstrated milestones and show that electric aviation is here and it's happening. So the first thing that we did earlier this year, around February timeframe, was we kicked off what we called the 916 Lima Foxtrot Roadshow. And if you come by our booth this week, you'll see 916 Lima Foxtrot. That aircraft is here. This aircraft was our first production intent CX-300. And when we took it on the roadshow, we visited over 80 airports, flying over 7,000 nautical miles. So this was a coast-to-coast journey where we basically took the aircraft, flew through 26 states, New York to California and back. We charged on our own infrastructure at nearly 50 Beta chargers that are installed across the US whenever possible. We did military exercises, flew IFR into Class B airports, flew past the Hollywood sign in Los Angeles. We also flew into Las Vegas. Navigated blizzards in the Midwest, did the Hudson Corridor in New York again, and stopped and did familiarization visits with the FAA, which actually allowed us to reach about 145 people from the agency to bring the aircraft in front of and do familiarization with, which was really great because a lot of the specialists that we work with have worked on our projects for years and hadn't ever seen the aircraft in person. So that was a really special moment for us, for them to actually get to sit in the aircraft and see what they've been working on with us. Most importantly, our main objective here was community awareness and familiarization. So bringing this aircraft to the public, touching that many communities as we went around, was really great, especially as we look at unlocking rural access and what can be done with this aircraft when you look at the cargo logistics, the medical logistics. So again, kind of looking at some of the benefits there. One of the projects that we did during the roadshow was we actually stopped in Utah. And this was more of a demonstration series where we actually worked with the state, we worked with a lot of stakeholders, and we completed 6 flight routes demonstrating the aircraft's ability to navigate the state and improve mobility. Hosted 7 events with a lot of notable figures, and we were able to also do a loading exercise with UPS, which is one of our key customers at Salt Lake City International Airport. You'll probably see footage up here of us flying in New York for the Port Authority demonstration with our passenger aircraft. So this was a history-making event for us where in June of this year, we got to fly the first ever passenger configured aircraft into JFK. Which was a wonderful reception by the city, by the Port Authority. We had FAA personnel there, and the controllers were really great to work with when you consider that this is one of the busiest airspace systems in our country. So that was a really monumental moment to bring the first AAM aircraft into that airport. From there, we began the European Grand Tour. So if you follow us at all, you've probably seen that we've been kind of traversing Europe. So November 214 Bravo Tango, which was our second aircraft off the production line, we took it over to Europe, and a lot of people ask why Europe? Why did we initially choose that? And Europe was chosen because we are going to be doing a demonstration series, a sandbox operation in Norway, actually starting next month with our partner and customer Bristow. So with Bristow, with the CAA that's there, we entered into a partnership agreement, and we will be conducting essentially a 6-month operation there where we'll be gathering data. So flying through Europe, we began our debut in the Shannon Airport. You probably saw footage there. Some of my favorite flying was against the Cliffs of Moher, just gorgeous, gorgeous flying. We crossed into the UK, where we stopped at the historic Boscombe Down for flying with the Empire Test Pilot School. And then we crossed the English Channel to France, where we then participated in the Paris Air Show. And that was a pretty historic moment for us in that we got to open the air show on that Monday. We were the first flight, which was a great moment for Beta and just to showcase American innovation and what we're doing. So great working with the DGAC and the air show organizers. And really, the reception in Europe has been tremendous. Can't say enough about that. From Paris, we began navigating up to Germany and passing through Germany, Denmark, and then, like I said, eventually we'll land up here in Norway in a few weeks. So this is just a graphical depiction of what I was talking about there. So you saw some of the clips there on the footage of the flying that we did across the U.S. So this is the road show that we conducted, showing all of the airports that we went across. So we started actually in New York, and that top line was the route out to the West Coast, and then the southern line was the route flying back. So again, over 80 airports, over 7,000 nautical miles flown. One of the really neat events, I guess, pilot perspective for me was that flying into Atlanta, when they flew into Atlanta, not only did they fly into Atlanta, but it was also night and IMC. So, to be able to do that and to say we did that, we obviously have worked with the FAA to get our market survey certificate, day, night, VFR, IFR, all, approved. But to actually go and do the thing was a really special moment for us, and to do it in Atlanta. Now, I know this is not the prettiest picture, and my creative team would probably be mad at me for sharing this and not having a better depiction, but I feel like as a highly technical group, you're okay with it. So this is directly out of our data dashboard. So this is the actual flight track of the aircraft as it's been maneuvering around Europe. So you can see there where we started in Ireland, went over into the UK, down across the English Channel into France, and then up through Germany. And we've made several stops there along the way, and getting ready to depart Denmark here shortly. So I'm going to talk fast because I'm running out of time, but I want to talk a little bit about the eVTOL side of things. So obviously there's been a large transition this year with the new administration. And what's been really great to see is that there is a focus on AAM, and in particular on eVTOL. So in June, we had an executive order that was released, Unleashing Drone Dominance, which was inclusive of what they call the EIPP. So basically, this includes an executive order that mandates an eVTOL pilot program be stood up in the U.S. That's supposed to accelerate, commercialization and integration into the NAS. So again, kind of demonstrating U.S. leadership in this space and recognizing that there are other countries in the world that are accelerating these products to market. So, this is kind of the administration's way to meet that and have us stay here and do this and safely integrate these aircraft into this airspace. So still waiting. We anticipate that the DOT will be, defining what this requirement set looks like. And we as the OEMs, are looking for, partnership opportunities and how to fully utilize this to demonstrate the benefits of this technology. One more notable thing that came out last year in draft form was the advisory circular for type certification of powered lift. So this has been something that, and I think David Dunning spoke earlier today, and Gamma was, a significant force in helping shape this and compiling all of industry's comments and feedback to get back to the FAA. But ultimately what this does is it creates a more streamlined path to type certification for these aircraft by establishing that set of airworthiness criteria that if you can meet it, it then negates the need for you to go through special rulemaking. So right now, historically, if an applicant needs to get their certification basis completed, they have to go through the public comment period. So it gets published to the NPRM as a notice of proposed rulemaking, gets to the Federal Register as a notice of proposed rulemaking, 30-day minimum comment period closes. FAA now has to go through those comments and review them, and there's really no time frame associated with that. It's just when it gets done. It has to go through the internal checks and balances, and then it gets published as a final rule. What we've seen with other applicants is that process, all said and done, can take 12 to 18 months, which is a significant amount of time in a type certification process. So having this in place is kind of that next step to how do we bring these aircraft to market in a more efficient way. So significant win for the industry. Beta is ramping up production, so we have a large production facility, and as I said, we've had the CTOL aircraft rolling off the line thus far in the Northeast up there. But we have spent 2 years developing these pilot production lines just to be ready. And as I said, now that we've got aircraft actually rolling off the line and getting those processes built, we're just looking at ways to maximize efficiency and what comes next. And that's a picture of our production facility. It's kind of an old picture. There's a lot more going on now, but you guys get the picture. And I was going to play a video, but I think I'm out of time. So I'll just end with saying that, we've hit a lot of milestones with our CTOL this year. This video here was of our VTOL transition footage, which, our VTOL is a lift plus cruise configuration. So recommend if you guys check it out. It's on our webpage and everything. Oh, we have time. Okay, great. There it is. Yes. So, again, as you can see, lift plus cruise configuration. And really what this does is this just demonstrates the transition from the vertical flight mode using the lift propellers to the wing-borne, where we're only using that pusher engine. Basically, this landing can be done, again, it can be done conventionally, just like our CX-300 airplane. Again, kind of when you look at the commonality between those training syllabus items. Or the lift propellers can be re-engaged to accomplish that vertical landing. So we've accomplished the full piloted transitions with this aircraft and continue to make strong progress in those test campaigns. So I'll leave you with what's next. I'll just say that we're continuing to get aircraft out in the wild. We have one coming off the line this week that is slated to go to New Zealand. So we are going to be also doing an operational demonstration series there. We've been working with our partner, Air New Zealand and the CAA. So going to have one in Norway, one in New Zealand. So really excited to have these aircraft coming out. But the last 2 quarters look significantly different. So our objectives are going to shift just slightly, and you'll see some more aircraft coming off the line to fulfill more commitments. So keep watching.
That was fantastic. And having seen the beta for the first time last week in Toronto, I'm very excited to see and meet your team here at Oshkosh. Okay, our next speaker is Michael Thompson from Skyfly. Michael started his career as a helicopter pilot before transitioning into UAVs and starting a services business providing surveys and inspections with drones using advanced sensors on UAVs. Through the combination of the experience and passion flying helicopters with the knowledge and understanding of flight control systems and the capabilities of distributed propulsion, he designed the AX alongside CTO and renowned aircraft engineer Bill Brooks. So he's going to present on his company. Please come to the stage.
Hi, everyone. So here today to talk about my company, Skyfly, and this is our 2-seat electric vertically capable aircraft. So we are here for the whole week on stand 421 at Oshkosh. We have had a bit of a disaster with our aircraft being held in customs in the UK for 2 weeks. So it will be here, but I'm not entirely sure when on stand 421. We'll be there all week, so please come over. I'm here with Dr. William Brooks at the front there. If you wave your hand, Bill. So he's the chief designer and chief technical officer as well. So any questions, go over to him. So yeah, the AX is a 2-seat aircraft primarily focused on the civilian market for personal use. We're also doing an unmanned version for defense applications. And then we also see this aircraft as a very capable training aircraft, 2-seat side-by-side configuration, and then also some emergency services applications as well. All this work. Okay, hopefully this video plays. So this is our first aircraft, serial number 1. So we've started the flight test campaign now with over sort of 50 piloted flights. And we actually recently completed the first airfield-to-airfield flight of an eVTOL, or vertically capable aircraft in Europe. So we've been flying out to Western in the UK. We were hoping to be flying into Oshkosh this year, but we're hoping to get an experimental permit to fly in the US this week. So we're sort of open to orders. We've got 42 paying customers across the world. On the military side, we've been enrolled on the MOD's heavy lift uncrewed heavy systems capability. So that's utilizing our aircraft as a device that can carry up to 200 kilos. So Bill is actually the one flying in the footage here. So this is actually some of the footage from our land away at Bicester. So it was a fantastic day, and the flight eventually was around 45 minutes, which was fantastic. So what are we trying to solve with our aircraft? I don't know how many people fly here, but when you look at what's available on the market for people to buy as a vertically capable aircraft at the moment, you're really sort of looking at a Robinson R-22. It's the most successful helicopter built, really, over 5,000 sold. But what comes with that? A very noisy machine, burning 10 gallons of toxic leaded fuel an hour, mechanically extremely complex. You've got many single points of failure, which in turn really make them quite expensive, not only in maintenance costs, but actually to buy them. In the hovering phase, I don't know if, again, learning to fly a helicopter is actually quite tricky, especially hovering. So there's no sort of assistance in the stabilized flight, no stabilized flight modes, which in turn leads to quite a few incidents. generally, there's not really been much innovation in this space. So that design, the R22, is sort of 50 years old. So there really hasn't been a huge amount of innovation in this space over the past 50 years. So this is our aircraft. So it's, as I say, 2 seats. We use complete composite structures throughout the whole aircraft. So in the wings, the fuselage is fully composite. So it's very crash-worthy structure. It's introducing all the new modern composite manufacturing techniques. We've got 8 electric motors. So on each wing end, there's actually 2 motors in one housing. That's for redundancy. So one of the biggest advantages, again, against sort of the conventional, even piston aircraft, fixed wing or helicopters, the noise levels. So we've been flying this aircraft now for a few months, and it's just incredible the noise levels that you achieve with electric propulsion. And also the level of vibration you have is just, and as Bill can testament, it's incredible. So it's a completely new way of flying, really, something that no one's ever really experienced. So in the hover modes as well, so we've got a quadruple redundant flight controller from a company called Invention. So this flight controller essentially in the hover phases controls all your movement, forward, back, roll and pitch, using distributed electric propulsion. So that, again, compared to a helicopter, you're essentially requesting an input. Wind, for example, any turbulence, the flight controller deals with it. So there's a lot less stress on the pilot, which in turn makes it a safer machine to fly in those hover phases, which is a sort of critical phases. Electric propulsion, again, the mechanical simplicity of electric propulsion means that your maintenance costs are much lower, which is a huge thing. An R22 costs around £300 an hour to fly. Our target price is around £70 an hour. And that's including things like your battery replacement, charging, etc. So the real cost benefit of this aircraft. So the design is quite unique. It's a canard configuration, 2 large wings, which enable it to glide. So this is a massive thing for us. Not only do the wings enable it to glide, but it's completely mechanically controlled with the control surfaces. So you've got a large fin and rudder, elevators and ailerons. And so these are all mechanically controlled, so no electrical systems required in forward flight to control the aircraft. So this is a huge thing for us, and I'll come on to it a bit later, but for pilot training and conversion from existing licenses, we think it's a real advantage. So any fixed-wing pilot can transition to this very easily. So I briefly touched on the flight test program. So we pretty much 5 years ago came up with the initial design for this aircraft. And in that period of time, we've gone from a sort of an initial 10th scale, which I didn't really have enough room to fit, and then a 3rd scale, and then full-scale aircraft. So the 3rd scale aircraft was a real amazing tool we had at our disposal, because we learned a lot about the airframe and how it flies. We were able to make very quick iterative changes to the design without huge cost. So then once we were happy with that, we locked the design down and went into full-scale tooling manufacture, and then made the first aircraft in February last year. So by October, we were doing the hover testing. So this was again in Oxfordshire. So we were essentially in a field for about 2 months, tuning this aircraft to hover. It was a very, very long process, but we got there in the end. We then took the aircraft back to the hangar, installed all the conventional flight controls, and then did our conventional CTOL flight testing, which was what we showed on the video earlier, which has been really good. We've decided that we don't have to make any design changes going forward, so we've locked that design down, and we're going forward with the next airframe build at the moment. So on aircraft performance, we're currently using cell technology that's quite old in this prototype. So the production version, we're going to go up nearer 300 watt-hours per kilogram in battery capacity, which give us just over an hour's endurance. So this, roughly speaking, gives us about 100 miles of range. And, when you look at there was someone else speaking yesterday on battery technology and how slow it's moving. Realistically, though, it is moving. It's going in the right direction. As a mitigation, and we've talked a lot about hybrid here, we are also developing a hybrid system for this aircraft as well, which we will see, increase that range up to sort of 300 miles plus. But yeah, for the time being, our prototype is fully electric. So customer groups, we specifically decided to go with vertically capable aircraft and not call it an eVTOL, because we do want to separate ourselves from the likes of Joby, Archer, etc. Purely because it's not the market we're going for. We're not aspiring to be an air taxi supplier. So the private pilot market, we feel, is a massively untouched market for this aircraft. So that's essentially, taking off from your house, flying to a restaurant, hotel, what you do with a helicopter, really, using existing infrastructure that's being used by helicopters right now. So we've got sort of around 800,000 pilots across the UK and the US that we're looking to sort of go for. And then, as I mentioned earlier, the pilot training market is quite a big thing for us. Whenever these larger eVTOL players get to market, there's going to be a huge demand for pilots, which is sort of under talked about, really. There's a lot of talk of simulator training, and in my opinion, you can't beat flying the real thing. So we look to sort of be the go-to provider for powered lift conversion training. So that's, again, it's a smaller subsection of the market, but we really think, again, there is going to be a real requirement for that. So then, obviously, with everything that's going on across the world, UAVs and drones have been a massive thing. So we're sort of very much technology agnostic in terms of our aircraft. The flight controller in it can be flown piloted, but also you can remove the pilot, and the same systems, pretty much everything apart from adding servos to the control surfaces, you can fly this aircraft autonomously. So we're looking at that market in quite a lot of detail for 200 kilos worth of payload. There's so many different applications in that market that we're looking at, and then sort of tagging onto that is the emergency services, so Medivac, etc. So this sort of timeline we're working to at the moment. So by Q2 next year, we want to be certified on a permit to fly, which is in the UK with the Civil Aviation Authority, and in the US, initially likely it will be experimental amateur built, and then as soon as those Mosaic regulations come into force, we'll be transitioning over to that with a light sport certification. But so for the next sort of 6 to 8 months, we're working on the next airframe, which is serial number 2, which will be the one that's type conforming and going through the certification process with the CAA. So yeah, we're just gearing up to get all that done at the moment. So then finally, I just want to briefly touch on the team who's delivering this aircraft, because we've really got a sort of world-class group of people. Not myself, but so Dr. Bill Brooks, he's sort of been my right-hand man since day one. I rang him up. I rang the CAA initially, and I said, I wanted to build this 2-seat electric aircraft. Who do you know that can help you? And I got pointed in the direction of Bill Brooks. So Bill came in and using his experience, 19 different aircraft designs, anything from a sort of flex wing all the way up to a sort of six-seat turboprop. Bill's done it all. And then we've got Sinjin, who you might be familiar with the Rolls-Royce Accel program, where they broke the electric speed record in the UK again. So he ran that project with his company Electroflight. So we've got a real good battery guy there. And then the two other guys, Chairman Richard Tuthill, he's just an amazing mentor for me, but his company called Tuthill Porsche, they're resto mod Porsches, but that's not really relevant. But yeah, that's it, and I will answer any questions probably at the end when they circle back round.
Our next speaker is Salim Sahir, Chief Commercial Officer of XTI Aerospace, which is based in Centennial Airport in Denver and developing a long-range, high-speed VTOL aircraft, the Trifan 600. Salim has been in aviation for a half a century. He started as a pilot in the Indian Air Force, flew corporate jets in the US, and most of the fleet of United Airlines. He has over 15,000 flight hours on 28 different aircraft types, including tail draggers, the MiG-21 Learjet, Airbus 320, and Boeing 777. In 2004, he transitioned to leadership roles and led flight operations for 3 airlines: Air Arabia in the UAE, Flyeti in Nepal, and Indigo in India. He was part of the leadership team that took Indigo from a small upstart into the largest airline in the country. He's been associated with XTI for 8 years.
Good afternoon, everybody. Before I get started, I just wanted to thank VFS for all they do, especially for putting this event together. There's so much great work happening here, and it is a privilege to be part of this team. And for all of us who are developing new airplanes and the associated systems around them, if I could wish one gift for all of us, it would be abundant and timely funding. I'll start with a video on the airplane, then we'll take it from there. So this is, I think we're the contrarians in this conference because we are the one company that is developing an airplane that is not electric and not hybrid electric. So starting with 2 traditional turboshaft engines, but there is a valid rationale as to why we are doing that, and I want to explain that as we go along.
Life is full of choices. Do I take the airplane with its high speed and long range, or the helicopter with its ability to take off and land anywhere? At XTI, we say, take both.
So the company is now called XTI Aerospace. We went public last year. We are listed on the NASDAQ. We trade as X-Ray Tango India Alpha, XTIA. And that umbrella company has 2 underneath it. One is XTI Aircraft, developing this airplane, the Trifan 600. The other is Inpiction, which is more into tracking devices, RFID, if you will, but more sophisticated devices. And as we grow, we'll probably have other companies under that umbrella because we want to get involved in what we're calling the vertical economy, which is other companies and other technologies that are associated or close to our primary mission here. So why are we not going electric with this particular airplane? It's all based on the mission. So unlike many of the eVTOLs being developed, we wanted to, right from the beginning, combine the best of a business turboprop and a turbine rotorcraft in one platform. Some of the defining level 0 requirements right from the beginning, we needed to have regional range, at least 600 nautical miles. We needed speeds of 250 knots or more, and IFR was a non-negotiable. For these kinds of missions, you had to be IFR and flight into known icing. So those are all basics for us, so to speak. So with those characteristics, there are many civil and military applications for this airplane under Part 91, 91K, 135. So corporate, air medical, charter, emergency response, air shuttle, and then as I explain some of the characteristics of this airplane, you'll see there are many military applications for it as a transport in different use cases within the military for ISR and other functions. So there are some companies developing eCTOL or stall airplanes. For us, we felt it was very important that we have VTOL capability. That ability to fly without the need to find a runway is very important to us, and particularly if you're trying to save time for your guests, your passengers, the ability to just operate from a landing pad, a backyard, a parking lot, a road, any place that's safe and legal was important to us. If you look at any population studies anywhere in the world, there's a UN report that is widely quoted which says the world is urbanizing. In the next 25 years, there'll be 1.6 billion more people moving into urban centers. So if you think traffic is bad today, it's going to get much worse in the years ahead. So we feel even if we could avoid even the drive to an airport, even if it's a corporate jet airport, is important so that you can take off from your backyard or a helipad close to you. So the conclusion, we all know, batteries are unable to do this kind of a mission for at least 20 years, if not more, which leads me to the next slide, which is our development history. So this company was founded in 2013, as I'm talking about XTI aircraft here. And the initial design was for 2 turboshaft engines at that time. Our first CEO was Jeff Pino. He was the president of Sikorsky, came and joined us as CEO. Unfortunately, died piloting his P-51 in 2016. Very tragic accident. That set us back a little bit. 2017, Bob LaBelle came and joined us as CEO. Bob was a former Navy pilot, had led several programs in the Navy, and then he was CEO of Augusta Westland North America and directly controlling the AW609 program before he came and joined us. So lots of very pertinent experience in our team right from the beginning. So as I said, batteries are unable for our mission. We explored hybrid electric for almost 4 years between 2017 and 2020. First with the Honeywell HTS 900, then the GE Catalyst, plus battery packs. We just found the numbers weren't working. The weight of the batteries was such that it negatively impacted payload and range. So we gave up on that. Then we tried for almost a year and a half to do hydrogen fuel cells. We worked with a company named High Point, which subsequently was acquired by ZeroAvia. But once again, we felt that there were so many unknowns in terms of certification timelines. Are the regulators ready for particularly things like hydrogen? Will there be sufficient charging infrastructure developed? If we come up with an airplane and it can only charge in 2 or 3 places, you're limiting its usability. So we felt rather than this devolving into an R&D project with undefined timelines and product, that's not what we were trying to do with XTI. We were trying to bring a unique aircraft to market. With this ability of combining helicopter and business aircraft, the best of both, we wanted to bring that to market because it was important to do so. So we didn't want to do an R&D project. We said, all right, we got to draw the line and start somewhere. Let's start with 2 certified turboshaft engines. It's difficult enough certifying a brand new type of airplane under the Power Lift 2117B. If you now add novel propulsion to it, you're just making your potential problems worse with timelines even further unknown. So we are starting with 2 turboshaft engines. I can't name them because we'll be announcing that when it is appropriate, but certified flying turboshaft engines. We start with those. We will make sure that those engines are capable of using 100% SAF. We all know that SAF is currently expensive and short supply, but we will do our bit to make sure that as and when it's available, it can be put into our airplanes. And if you can do that, you have an 80% reduction in lifetime CO2 emissions. So that is phase one. We'll keep monitoring hybrid electric developments, whether it is batteries or hydrogen, and when it is appropriate, we will switch to them. And then maybe in 30 years, switch to all electric, but we are not going to sacrifice the mission. So we remain committed to sustainability, as I said, starting with turboshaft engines. That helps de-risk the program quite considerably, accelerates certification and entry into service. Also, the airplane can be used immediately without any ground charging infrastructure needed. So upon entry into service, worldwide deployment. So it's just a measured risk phased approach, we say, tied to the tech maturation, formulation of regulatory guidance, and the development of infrastructure. And then we'll switch to hybrids when the time is right. And then, as I said, finally to all electric. If you study actual business aircraft usage, and this has been true for about 20 or 25 years now, for the markets we are targeting, which is, corporate, VIP, fractional, charter, 91, 135 kind of operations, there's some pretty interesting statistics out there. There was a study done in 2009 by a company named Harris for NBA and Gamma. There's more recent data available from 2021. And what it shows is, and this is for all business jets combined from the, let's say, the Phenom 100 going to the heavy, Gulfstream 800s, etc. If you average it all out, they have 4 passengers or less. They fly 1.9 to 2 hours on average. That's the trip length. And 70% of them fly for 2 hours or less. And then when you look at the top 10 business aircraft routes in the US and in Europe, 8 of them are less than 350 miles. So this airplane, with what it is capable of doing, caters for all of those. And it gives you the added advantage of not needing a runway. Just find a flat spot wherever it's safe and legal, take off from there. These are some of the routes which are the busiest in the world: New York to DC and Boston, London to Paris, Paris to Geneva, LA to Vegas and San Francisco, Geneva to Nice, Milan to Rome, all under 350 nautical miles, about an hour and 20 minutes, hour and a half for our airplane. Look at the design. We have 2 ducted fans ahead of the wing. We have 1 ducted fan in the aft fuselage. Ducted fans, we've found in the testing done so far about 30 to 40% greater thrust because of that duct compared to an open prop. The noise is slightly lower than an open prop. And we think the downwash, outwash will be more contained rather than flowing outward to a greater extent. Vertical lift capability comes with all 3 of these fans in this position operating for vertical takeoff and landing. Once you have taken off and you start transitioning to forward flight, the front ducts swivel and the aft duct shuts down and the doors close. Engines will be certified, proven flying engines, already got millions of hours on them. Again, as I said, that de-risks our certification path. Fly-by-wire controls are important, particularly for duct transition, so that's what we'll have. The airplane will be capable of flying at 25,000 feet pressurized, excellent visibility, as you can see in those windows in the cockpit, and not so easily discernible are chin windows or cheek windows that are just outboard of the pilot's feet for vertical visibility. VTOL range, 860 nautical miles, we're saying 1,000 miles statute. Again, don't hold me to these numbers. They will keep changing. The aircraft is not totally defined yet. We expect CDR, critical design review, sometime next year, which is when we'll finalize the design, and these numbers will become a little bit more, sort of fixed in stone, if you will, at that stage. But 270 knots, 25,000 feet pressurized, IFR, no icing, operate from helipads, firm ground, airports, and those circles show you that it truly is a regional airplane. So this is Los Angeles, and I don't mean an airport there, I mean a helipad there, all the way to Denver and Seattle. Similarly, from Manhattan Heliport, you can go to Vertiport Chicago, Memphis, all of the Northeast. And again, no ground charging infrastructure required. So wherever helicopters are operating today, pretty much, this will be able to operate without needing any ground infrastructure additionally. The main thing these airplanes are going to give folks is time savings. And this is just a chart showing a flight from downtown LA to downtown San Francisco. We anticipate by the time we come to market, there will be some heliports in operation in those cities. 300 nautical mile trip will be fairly standard for this airplane. So this is door to door. You leave your home or your office, you get to a helipad, you fly, and you do the same thing at the other end. It's 1.8 hours for the trifan, 2.2 hours for a business jet, and at the other end, 4.5 hours for an airline for all the reasons you know. So even compared to a business jet, you're saving about 25 minutes and 2.5 hours each way compared to the airline. So if somebody is going for a business meeting, that's 5 hours returned to you as a wonderful gift. The airplane is capable of all three modes. You can take off vertically, and it'll be the defined certified weights. If you want to increase payload, just a short runway available, a grass strip, or even a football field-sized space, you can take off with the ducts in an intermediate position, utilize that to increase payload, and then if you have a runway available, and not much, about 1,800, 2,000 feet, do a conventional takeoff and increase your payload even more. Configurations, the business configuration is club seating for 4 at the back, 2 seats. The aircraft will be certified single pilot IFR, but it will have controls in both pilot seats in the front, and baggage space for 10 rollerboards behind the seats. We're also considering some baggage space in the non-pressurized cabin in addition to this. Air medical, 1 stretcher patient, 3 attendants, and then we also have an air taxi configuration where you put another seat in the aft row. So 5 plus the seat next to the pilot, so 6 passengers plus 1. Running out of time, this is just a platform comparison of us versus the eVTOLs, helicopters, business airplanes. All of those are obviously for different missions, but because we're combining the best of both the business aircraft and helicopter, we tick many of the boxes, whether it comes to range, speed, infrastructure, payload, IFR, etc. So to conclude, we are committed to a more sustainable future for aviation. As I mentioned, we're just doing it in a phased manner, given where the tech is, where the regs are, and where the infrastructure is. If you follow XTI Aerospace, many of our PR press releases in the recent past, you'll see we are focused on what we're calling the vertical economy. So a lot of adjacent platforms and technologies will become part of the XTI Aerospace umbrella in the years ahead. So whether it's hybrid electric propulsion, you'll see one press release. We did it Vertigo. Eric was here yesterday to just keep exploring hybrid electrics, both for the 600 as well as for smaller platforms, both for cargo and military applications. Next-gen manufacturing, airspace infrastructure management, the inclusion of AI into all these processes, and advanced materials, all under consideration. That's all I have. Thank you.
Okay, we have about 8 minutes for questions and then a break. We can actually go a little bit longer. So are there any questions? I neglected my glasses at the back, but it looks like Joshua over here. Go ahead. And our other panelists, could you please come up in case there's any other questions?
Great work by all airframers. But there is a theme I'm seeing with all 3 of these airframers, so I'm going to ask a difficult question. How do you handle ingress fault tolerance for like bird strikes with only 3 or 4 VTOL propellers? How has that been sort of considered, and what's the FAA's view on ingress fault tolerance in a hover? Thanks.
Was that for you or the other?
All right, is that for me, Joshua? Yeah, no, so this airplane has two turboshaft engines, it's got a combiner gearbox. So the case of one engine failing is really not much of an event because the other engine can supply both the fans, in fact, all three fans. The most critical scenario is you're doing a vertical takeoff and one engine disintegrates, one ducted fan disintegrates. So we've got to have to prove that to the FAA that it meets whatever, 10 to the -8 or whatever it is. We're not quite there yet, but that will have to be proved. So I don't have a specific answer, but that has to be part of the certification process.
Yeah, cool. Just to clarify, I specifically mean ingress, like bird ingress, so coming into the propeller.
Yeah, so whether it's that
the
or,
charge.
just there's a delamination and things just fall apart, the effect, I think, is going to be similar.
Thanks.
Yeah.
Can't see Michael, or Michael seems to have aged a lot all of a sudden. So the question was about bird strike?
Yeah, ingress handling single propeller failure of the 4 propellers.
In our case, we can just glide. That's the short, simple answer, really. The only other consideration is on our Skyfly is on the front rotors with ground contact. And because of that, we've designed it as an H configuration drone where the front propellers contra-rotate so that should we get a ground strike, any debris is ejected outwards away from the cockpit. And the rear ones are quite high up anyway.
Thanks.
Thank you.
I don't know if Peter had any comments about ingestion redundancy if you had a bird on hover. No? Okay.
Sorry.
Yeah. Thanks.
Hi, my question's about charging. So beta, I think of beta as being really great in the charging space. You guys have pushed a lot of boundaries. And the charging network and everything is really quite cool. The choice for CCS couldn't have been super easy, right? Like, if it seems like a lot of aviation is going towards CCS, but Pistrellus sort of shook GBT, and maybe that doesn't matter anymore, hopefully. And you guys have gone CCS, and Archer and H55 and lots of others are following. Joby with their GEACS, I think they have enough letters in that one, but I think I got them all too. But yeah, I don't know. How are you feeling about it? Is it working so far? Do you think it's going to need a new standard, or is CCS going to be like long term? What's your stance? And I think for Skyfly, my question is more like, what charging do you use, I guess. But for beta, I'm definitely interested to hear like how the choice of CCS is sitting with you. Yeah.
Sure. So my disclaimer is I'm not the charging expert necessarily here, but I will say, obviously there was a lot that went into that choice, and I won't try to speak on behalf of the engineering team that made that decision, but it did feel like the natural choice in terms of ease of integration. You look at the fact of, right now, it's very nice for me from the regulatory standpoint when I'm having these conversations with airports, with the regulators, on integration, and how they're looking at this, because it's not just, hey, we can put this on the airport and it can only charge beta aircraft or only charge beta aircraft and Archer aircraft. It can charge the ground fleet as well, right? So I think that as we're looking at the integration piece, that's the part when I look at CCS and the benefit right now anyways, is that we're able to go to these airports, and one of the feedback items is, well, but how soon are we going to have electric aircraft coming here at a rate that would warrant having a charging station, right? And so I think, one, telling them we have this ability to do it, and multiple operators have signed on, to have this common charging standard, meaning that there will be 1 versus 6 sitting out here on the ramp. And then also, like I said, you guys can put it on your airport now, and you can use it to electrify your ground fleet, so that it's not just sitting there. As we know electric aircraft are coming. But yes, it's going to take time to get to the numbers, to really see, lots and lots of charging iterations unless you have a fleet that are stationed there, right? So I guess that's kind of my thoughts right there. Anything?
There's a company in the UK called Aerovolt who have been installing chargers around various small airports, airfields. Our prototype aircraft uses a very low voltage Geiger system, which is great to get us testing, but it takes ages and ages to charge. But yes, for our Mark II aircraft, we're redeveloping the power plant to use the Aerovolt chargers and a 400-volt system.
And I have to be cheeky and say we don't have that problem.
Another question from the floor. Go ahead.
Kristen, for Beta, what is y'all's estimate for the CTOL certification? Do you have some?
Sure. Yeah. Right now, like, and how I usually try to couch this is that everything that we have is a projection, right? Based on the information that we have today. There's a lot that we're working out with the FAA. And like we said, we have 3 concurrent type certification projects with one certification team. We're not a large company, with unlimited resources, but working towards that initial type certification of H500A, which will be ported into the CTOL, has really been the focus right now. And we're actually looking, at that being completed by the end of this year or Q1 of 2026. The CTOL projection is end of 2026 to early 2027. So that's what we're projecting today for those certification timelines.
Okay. And can I ask one more?
And I'll disclaimer say, as a regulatory person, I will always give a range because there's just got to have that.
I'm gonna take the time to ask one question which is UK and Europe. So one for Beta in Europe, what's your approach on certification, or how do you see that shaping up both for eCTOL and for eVTOL? And in the UK, can you explain what the certification environment now is in the UK, and its relationship with EASA and FAA, if you feel that you can speak on that?
So we've been in discussions with the UK Civil Aviation Authority, and we are going for a UK CAA permit to fly, and we're going through compliance with a compliance checklist with EASA VCA, SCVCA, and trying to meet as many of those requirements as possible, or submitting an equivalent safety case where we can't. So we'll see how we get on with that. Our home-built organization, the LAA, don't have the CAA authority to deal with electric aircraft at the moment, or certainly not electric vertical takeoff aircraft at the moment. So we're going straight to the CAA, and they've been very understanding so far.
So a couple of notes on that. So we, during basically our European Grand Tour, as we call it, so we were able to accomplish that obviously using our FAA experimental airworthiness certificate. But then for each country that you fly into, you have to go through the permit to fly process. So going through the UK, we got our permission from them, worked with the UK, obviously sharing some information there to make that happen and to do those flight operations. And then for every other country that we went through. So I will say that we've had some introductory conversations just on the operational side with the UK. But EASA, so since they're not part of issuing those operational permits, we did give them kind of the awareness that we were coming over, as a courtesy, and we've done some familiarization with them, had a couple of meetings, and we were able to actually bring our aircraft through Cologne, where their headquarters is, and so we were very fortunate to have them come out and see the aircraft as well. They've also been kind of an observing party with the Norway operation that we're doing at the end of this year. So a lot of conversations and just awareness going on, and obviously what we're always driving towards is those supporting those conversations between the authorities as they work towards those harmonization and transferability, discussions. So we always kind of say defer to the regulators, but in those ways that we can help shape those conversations and give industry data and feedback is obviously important, especially as we're out doing this real world flying, providing that data to them. One piece I will speak to on the CTOL just real quick, and not to go too long here, but obviously there are some regulatory hurdles in Europe with flying night and IMC with a single engine. So if you're familiar with the CAT-SET IMC rule, it's basically single engine turbine for IMC. So if you have a single engine turbine aircraft, you can do commercial operations, through this regulatory route. They haven't developed that language for electric propulsion. So one thing that we've been talking to EASA about is just, hey, something to consider in the future is, for us to do that right now, it's an exemption pathway with the member state for the operator if they wanted to do that night or IMC flying with a single engine electric aircraft. And so as they look out at their regulatory priorities, flowing in some propulsion agnostic language because electric engines are just as, if not more, reliable.
I have another question for you, Kristen, if you would stay. On the test operations you're planning in Norway with Bristow, are this being, let's say, real transport operations with cargo, or is it just flying from A to B to prove that it can fly, but not transporting something? Because I know in Norway there is, over the company Widerøe, there is this public-supported transport system of aviation, and they are transporting a lot of goods, and there are no streets or trains between the cities along the coast. So where exactly will this be operating, and what will it be transport, if it will be with transport?
Absolutely. No, it's a great question. And right now, this is a demonstration only. So there will be no transportation of actual cargo or anything there, just to keep in line with what is permissible underneath the permissions that we have been granted by the applicable authorities. But really what this is about proving out how to integrate electric aircraft into the Norwegian landscape. So we're basically working with the regulators and a few other partners just in kind of that gathering of data. We have very specific objectives and milestones that we're hitting throughout the project to kind of expand the envelope and see what's possible there.
So we're eating into break, so if those want to go to break, but I will...
This is just to share an experience with everyone. I was lucky enough to fly on Beta during the European tour, and I just wanted to tell everybody how amazing it was. I've flown the Pipistrel for a year, but this was equivalent of stepping into a science fiction film. Hello to everybody online. Thanks for staying with us. Just to share the experience on flying on an electric aircraft, I've flown the Pipistrel for a year, and everybody I've flown in that aircraft, from military pilots, civilian pilots, young kids, just love it. You can see the smiles. But when I was lucky enough to fly on Beta at Farnborough Airport, I took it for a couple of circuits. It was mind-blowingly amazing. The size of the cockpit, it's huge. The visibility, there's nothing around you apart from sky. You're like in a bubble. It's so quiet, there's no vibrations. Passengers are going to love these aircraft. It's going to be addictive for them.
That was not an audience plant.
That was actually one, we're cutting off the questions. That was actually a representative from FlexJet, from the fractional ownership and the helicopter side of things. Okay, it is break time, and unless I've screwed up again, and we're reconvening at 3:15.